YOLO11 is the new state-of-the-art model released by Ultralytics that outperforms all the previous object detection models, including YOLO v10, YOLO v9, YOLO v8 in terms of speed and accuracy. YOLO11 can be used for a variety of tasks such as object detection, instance segmentation, image classification, and pose estimation. In this tutorial, we will look at how we can run YOLO11 in our Windows. And here you can see the GitHub repo. So this is the Ultralytics GitHub repo over here. And here you can see the graph. So you can clearly see that YOLO11 models outperforms all the previous object detection model in terms of speed and accuracy as well. And here, if you want to check the documentation, you can click on the link over here. And YOLO11 can be used directly in the command line interface with the YOLO command. And in this tutorial, we will look at how we can use YOLO11 directly in the command line interface with the YOLO command. And you can also set up a Python script and you can just write down this script and you can use the YOLO11 model as well. But in this tutorial, we will see how we can use YOLO11 directly in the command line interface with the YOLO command. Okay, and in the later videos, we will see how we can set up the Python environment and just set up all this script. And we can, but in this tutorial, we will focus on how we can use YOLO11 directly in the command line interface with the YOLO command. So YOLO11 comes with 5 different models, which include YOLO11 Nano, YOLO11 Small, YOLO11 Medium, YOLO11 Large, and YOLO11 Extra Large. So YOLO11 Nano is the fastest among the YOLO11 models, but it is less accurate. Like you can see over here, the mean average precision validation is 39.5. While YOLO11 Extra Large is the most accurate, as we can see over here, the mean average precision is 54.7, but it is less fast, or like it is not very fast as compared to other YOLO models, YOLO11 models. So there is a trade-off between speed and accuracy. Okay, YOLO11 Extra Large gives us the better mean average precision as compared to other YOLO11 models, but there is a trade-off with the speed, like the speed is slow or it is less fast as compared to other YOLO11 models. So here we have that these are the object detection models. Here we have the models for instance segmentation, and here we have the models for pose estimation, and here we have all the models for image classification as well. So you can just check out this repository. You can check out different examples on the Ultralytics documentation as well. So let's start writing down the code and see how we can run YOLO11 in our Windows. So here you can see I've just opened Anaconda prompt. If you have installed Anaconda Navigator, you can open the Anaconda Navigator, and over there you can open the Anaconda prompt. So over here you can see that I have opened the Anaconda prompt. So the step number 1 will be to set up the virtual environment. So in the step number 1, I will set up a virtual environment. So to set up the virtual environment, I will write conda create -n, and here we will write the name of the virtual environment. I will write YOLO11 OD. Okay, so this is the name of my virtual environment, and I will be using Python 3.10, which is installed on my system. So first of all is we need to set up a virtual environment. So this will take few seconds to set up the virtual environment. So we write Y over here. So this will take few more seconds. So let's wait. So now we need to activate our environment. So I will write conda activate, and the name of my environment is YOLO11-OD. So let's run this. So now you can see that I have just activated my environment, and you can see the name over here. So we can clear the screen. Okay. So now we have set up the virtual environment. Now in the next step, we will set up the YOLO11. So we will install the Ultralytics package over here. So I will just right pip install Ultralytics over here. So I am installing the Ultralytics package. So with the Ultralytics package, like you can see that many other packages like NumPy, Matplotlib, OpenCV Python, SkyPy, Panda, Seaborn, and many other packages also gets installed as well. You can see there are large number of packages which are just getting installed. So this will take few more seconds. So now you can see that it's installing all the connected packages. So there are like many packages that are installed along with the Ultralytics package. So let's wait for a few seconds. So now you can see that all the packages are installed. So we can first clear the screen, and then I will just write Python over here. I will just write import torch. And over here, I will just write torch dash version to check the torch version. So we have 2.4.1 and CPU because I don't have GPU available in my local machine. Then what you can do over here is with Z from here, we can simply write this Z and yeah. So if you have a GPU available in your local machine, you can simply write pytorch.org from here. And then you can click on get started from here. Okay. And if you want to install torch with GPU, so you can simply type 2.12.4 over here. Okay, and just all same. And then you can just copy this command from here. And then you can go back over here and you can just write this over here. As I don't have a GPU in my machine, so it's no usage. So I will simply stop this operation. But if you have a GPU and available in your local machine, then you can simply use torch with GPU. And after installing this command over here, you can then just write Python over here. And then you can write import torch over here. And you can simply write torch.dash version. Okay. So currently I don't have a GPU, so you can clearly see CPU over here. But if you have a GPU available in your local machine, like if you have NVIDIA GPU available in your local machine, then you can install GPU version of PyTorch. So to install GPU version of PyTorch, we just need to simply run this command. After the installation gets finished, then you can simply write import torch and you can check the version of torch. So here you will see the CUDA over here. So if the CUDA appears instead of CPU, so it means that you are using GPU version of PyTorch. And the CPU version will be automatically deleted. Okay. So we can simply exit from here. One thing I just forgot to tell you. So you can one thing further check is import torch. If you want to check if you have if the PyTorch GPU is working, so one thing you can do is you can write torch.CUDA.is-available. So you can see false because as the GPU is not working, so you can clearly see false over here. But if you have a GPU working, then you will see true over here as well. So we can simply exit from here. And I can just clear the screen. So we have set up everything. So now what we can do over here is, we will see how we can do object detection on images and on videos over here. Okay, so we will be using YOLO11 directly in the command line interface with this YOLO command over here. Okay, so what we can do over here is we can simply write YOLO toss is equal to detect, mod is equal to predict, okay, and model is equal to YOLO11. We are using YOLO11 nano model, and for the source, and inside this folder over here, YOLO11 window report. If I just show you, so I have added these 2 images and 1 video. So I will use this image.jpg over here. So I can simply write source is equal to image.jpg. And let's see if we are able to do object detection on this image or not. So this will take few seconds. First, it will install the YOLO11 nano model. In the meanwhile, it gets installed. Let me just so you can see that our output is saved into runs detect predict. Okay, and we are able to detect 12 person, 1 bus, 2 traffic light, 3 backpacks, and 1 handbag. Okay, and let's go to this folder. So you can see here we have the runs folder being created, and inside this we have predict. And over here, you can see over here we are able to do detect bus, person, backpack, handbag, person, traffic lights. So the bus, so the detection results are quite good. Okay, so let's go back over here, and similarly we can do object detection on video as well. What you need to do is, instead of source over here, you just need to pass the video.mp4. So as I'm running on CPU, the processing will be very slow, but I will just show you how this works. So now you can see the complete video is divided into 458 frames, and we are doing detection, object detection on each of the frame one by one. Okay, so let's wait for it to get finished, and then I will show you the output video as well. So the processing on the video is done. Let me just show you. Over here we have predict 2, and over here we have our output video. So let me just show you the output video over here. So over here, you can see that we are able to detect person, bicycle, traffic lights over here. And we can also able to detect the road signs over here as well. So the results look very promising. Like you can see, we are able to detect handbag, person, traffic lights. So overall, the results look quite good. Okay. So we have seen that how we can do object detection on image and video. Now we will see how we can do instance segmentation or object segmentation on image and video. So first I will just write over here. First I will just clear the screen. Over here I will just write CLS. And to do object segmentation or instance segmentation, I will just write toss is equal to segment over here, and I will also write over here the source. I will pass the input image over here. I will just write image1.jpg. So now what we are doing over here is we are doing instance segmentation on this input image over here. And currently we are using the pre-trained model. So we are just writing mod is equal to predict, and we are doing the prediction using the pre-trained model. Okay, so it's done and results. Okay, mod toss is equal to segment. Mod is equal to predict. Okay, let's see. So it's doing object detection. I might have made a mistake. So let me just see. Toss is equal to segment. Mod is equal to, okay. So basically I'm using object detection model. I need to use the segmentation model. That is the mistake. So if you just go over here and see, we have the segmentation model. I need to use this model. I was using object detection model. Therefore, I was just getting this issue. Now, hopefully this issue will be sorted out. So let's see, this will take few seconds. So now first is downloading the segmentation model, as you can clearly see over here. So now its results are saved in segment predict folder. And let me just go towards this folder. And here you can see we have the segmentation folder in the predict. And here you can see we have the output image. So now you can see that we are able to do instant segmentation on bus, traffic light, person, handbag, backpack. So, and the results look quite impressive. Like you can see, these are the instant segmentation results, and the results look quite promising as well. And to do instant segmentation on videos, what you can do is you can simply replace the source with the name of the video, file name like video.mp4. I will not go towards it because I'm just running it on CPU, and the processing on CPU takes a lot of time. So we have seen that how we can do object detection and instant segmentation. Now we will see how we can do pose estimation on image and video. So to do pose estimation, first of all, what I will just clear the screen over here, and we can just update our this is toss will be equal to pose now, and we will be using YOLO pose model over here. And over here, what we can use simply this image. That's what. Let's see if we are able to do pose estimation on this input image or not. So this will take few seconds before it gives. So now it's downloading the YOLO11 pose estimation model. So now you can see the YOLO11 pose estimation model is downloading, and we are able to do pose estimation on this input image. So let me just go over here, and you can see the pose folder over here. And here you can see that. So now you can see that we are able to do pose estimation on this input image. So YOLO11 pose estimation model is being trained on for the person poses. So it will only detect pose for the person. And if you want to detect the pose estimation for any element or for any object, you need to fine tune the YOLO11 model. Okay, because YOLO11 pose estimation model is being trained to do pose estimation of only person. And if you want to do pose estimation of any object or any animal, you need to fine tune the YOLO11 pose estimation model. Okay. And in the same way, we will also see how we can do pose estimation on a video. So we can simply write over here video.mp4. So now we are doing pose estimation using YOLO11 pose estimation model on the input video. So this will take quite some time. Like you can see over here, the complete video is being divided into 458 frames, and the processing on each of the frame is done one by one. So let's wait for it to get finished, and then I will show you the output video as well. The processing on this input video is done. So I will just go over here and open the predictive folder over here. And let's see if we are able to do pose estimation on this input video or not. So now you can see that we are able to do the detection and pose estimation as well. So you can see the results look quite promising. Like you can see, we are able to detect the person, and we are also able to do the pose estimation as well. Okay. So now we are left with only one task, which is classification, like image classification. So what we can do is, first I will just clear the screen, and I will just write over here toss is equal to classify. I think this is correct. And we will use classification. Okay, plus let me just check it once. Okay, for the classification, we have SCLS. So why not use the extra large model? X-CLS, and I will just pass the car image. So what's the spelling for the car image? Car image. Okay. That's in the PNG or JPEG. That works. Car image dot. So let's run this. So first it will download this model. Let's see. You can see the model is downloading. The size of the model is 6.9. Like the YOLO and YOLO11 extra large model is 10 times larger in size than the YOLO11 nano model. YOLO11 nano model is around 5.69 MB and YOLO11 extra large model is 56.9 MB. So it's around 10 times in large in size as compared to the YOLO11 nano model. So now it's done, and you can see we have saved our result in runs, classify, predict. So if we just go over here and predict, let's see how it works. So over here, you can see that if you can zoom in the screen, so you can clearly see over here, the model has given me like the model is 66% confident that the sports car, and yes, this is a sports car. While the model is 11% confident that is the car wheel, 10% confident that is the cap, and only 3% confident that this is a racer. So like 66% the model is confident that this is the sports car. So we are just getting impressive results. So in this tutorial, we have seen that how we can run YOLO11 in Windows, and we have seen that how we can run YOLO11 directly in the command line interface with the YOLO command. So that's all from this tutorial. Thank you for watching.